So this is the central portion of Vatsalya campus where all of the energy needs of the campus is met, except for a few water heaters where they have a local level water heating systems. But let's go to the Sheffler reflector first. So that reflector was assembled in 2013 with the help of Wolfgang Sheffler himself, who came here to support us with the installation. And this reflector basically provides us complete energy satisfaction for 150 persons, 100 odd children plus 50 odd staff. And it has been doing so since 2013 January, and this is 2022 January. And earlier we used to have 15 to 18 gas cylinders, LPG cylinders usage per month for this food, and this brought the number down to two LPG cylinders per month average for the year. And we have been using it very effectively, and all the personnel over here, the women, are trained how to use it, how to adjust the seasonal tracking mechanism also. And it has cooked somewhere around 150,000 kilograms of food till date. It paid for itself in like 4 or 5 months, I think. And if there is no sun, we have another reserve. We have our own cows, and they of course provide manure other than the dairy part. The manure is fed into that biogas chamber over there, and that initial is the compost pit, is the feeding chamber. Then you go to the gas chamber where there is a huge rock type structure which pressurizes and releases methane gas to this mechanism above back into the kitchen. And back there behind that is actually a compost pit which you cannot see right here, and that compost pit is used to grow these crops over there, and that is also grown through rainwater which is harvested through all of the rooftops over there, connected through a tributary system. So it is a very beautiful big cycle, and that way again the food for the cows and of course humans is grown, and then again the cycle repeats. So that was about the biogas. And here if you see over there, that is an off-grid 20 kVA solar plant, polycrystalline panels, but all of it was done in-house. No outside company coming in and doing this installation. All of it was done in-house using our in-house trained solar technicians and engineers, and it had paid for itself. I think 6 months ago it was inaugurated in August 2018, and so we do not take any energy from outside for electrical needs, for cooking needs, and next we just go to the baking. We'll go to that now. So we'll understand the tracking mechanism of the Sheffler reflector at Vatsalya. This is basically a fully automatic system. You just have to do the seasonal adjustments. Let's see how this works. So over here on the front end part, we see a photo transistor right here, which is half covered by a shadow of a bent iron sheet. Now what happens is that, let's come behind and understand it. What happens is that when that photo transistor is exposed to light, it completes a basic circuit which is connected to that PV powering a motor over here, which is in on condition right now. So we hear the motor moving, and that motor within this housing, it is connected to this clutch mechanism over here, and that is connected to this bicycle chain, which is exactly at the inclined at the latitude angle along the axis of rotation of this true north-south based 10 meter square paraboloid, and this is 27 degrees here. and then that pulls the chain slowly in the morning and evening position. And what happens is, right now the reflector will rotate like this, and there, like this, analogous to this is the morning switch, and that is the evening switch. So that evening switch will turn the reflector back to the morning position in the previous evening. And how it does that, it just reverses the polarity, and the motor comes back, and this morning switch, you can call it just a magnet, it again reverses the reverse polarity of the motor, and the because then the sun is towards the evening side and the reflector is entirely opposite, then it just stops because the phototransistor is not getting any signal. And this is how the tracking mechanism of this reflector works. Wonderful aloo mangodi sabji vegetable being made for the children and staff of Vatsalya using the 10 meter square Sheffler reflector. Okay, so regarding our campus's baking needs, there is a long history, but I'll just try to put it in a brief. Basically, we had a conventional wood fire oven, and it was not an oven, it was a room, and a large bhatti, we call it in Hindi, and the wood would have to be specially prepared, and the room would have to be heated. The baker would stay up overnight, check the wood. If it is raining, then you can forget about the baking, and of course you release a lot of carbon dioxide and pollutants into the atmosphere, and then the bakery would run 3 days continuously per month. And so, like, all the celebrations and special food, special baked items would be only on those 3 days. And okay, sorry, there was a bell in between, and I asked my videographer to stop. Anyway, that's the lunch bell, and people are going to come for that. Anyway, so we needed a solution. So we had the Sheffler reflector, and we thought, why not use it for baking? But then you cannot use it without the sun. Of course, there was that catch. And of course, Sheffler was already being used for the entire remaining food. So you can either you need another reflector, or you need a solution which could also be, providing power throughout the day without the sun also. And we thought, let's just take a conventional oven and power it by PV. I know the energy conversion efficiency is low from electrical to thermal, but we gave it a thought, and we powered a small 2 kilowatt oven, and that would feed only 3-4 children, and we have 100 over here. So me and few other folks went to Delhi and searched for good ovens, energy efficient ovens which would serve 100 odd children, but then they would be costing about 10-12 lakh rupees, and also they would require 12 kilowatts of energy, and that is really not efficient. So once we had the PV in place, we thought that the oven is basically an insulated chamber with convective fan and heating elements, and more the insulation, better the heat retention and efficiency. So first, let's see the oven, which we made from scratch over here using 70% scratch. So this is normal trunk galvanized iron sheets outside, 4-inch rock wool insulation. This is all 4-inch inside, and then here we used Borosil evacuated tube glass, which is thermally resistant. Devashish, may I open it? Yes. Okay. And right now paws are being baked here. You can see. So we have 2 halogens on the top over there, 2 halogens, and a 1.5 kilowatt heating element at the bottom, 1.5 kilowatt heating element at the top, and each halogen is exactly 500 watts. So that makes it 4 kilowatt with the space of 760 liters. We have successfully baked 230, 250 pizzas in one day using this oven. So I just disturbed a baking session and a vocational training class. These are some children of Vatsalya. Say hello. Hello. This video will go throughout the world. पूरी दुनिया में लोग देखेंगे. Hello बोलो अच्छे से. Hello. So they are undergoing baking training also, solar baking training, and Devashish is the master chef. He will also be attending the conference. And so this solution, powered entirely by PV, the off-grid PV, gave us a way to use solar power at its optimum during the day, and it has worked.